Well, hi everyone. All right, the last of our conic sections that we're going to discuss, I think, will be hyperbolas. Um, what I want to do, I think I just want to start with a equation, a hyperbolic equation. Okay, so what I want you to see here is there's a subtraction here between the two terms. If we had an ellipse, it was both terms we had a positive here. We still have this equals 1 here, so that's kind of a difference there. I just want to show you how this particular hyperbola is graphed, and that I want you to also understand that there are two parts. There are two curves involved with the hyperbola. So I'm going to draw the axes here. All right, there's my x and y axis. All right, now I want to kind of build the framework for this. So now x squared is over 4. So we're basically talking about x squared. I'm going to rewrite this as x squared over 2 squared minus y squared over 3 squared is equal to 1. So from the origin, which is the center of this hyperbola, I'm going to go 2 units this way and 2 units this way, and that's, again, I'm just building a framework right now, and then I'm going to go 3 units. That's what you have under your y there, above and below the center. And I'm going to kind of just make a rectangle here, or a box. And what this has helped me do, and it's helped me to build through the diagonals, I'm going to draw the asymptotes. The diagonals of this box, of this rectangle, would be the asymptotes. So I'm going to make a dotted line going out like this. Let's see. And here. Okay, those are the diagonals of my hyperbola. Diagonals. These are the asymptotes. I'm sorry. These are asymptotes. And now I have the vertices that I want to draw for each of the curves. Okay, one vertex, and if x is first, it's going to be along the x, it's going to be along this, the horizontal part of it. And it's literally just the edge of that box that we do this. And the curve is going to, it's going to be close. The further up you go, the closer to the asymptote you get, but then you kind of get away from the asymptote a little bit and you come toward the curve. So you got this, you hit that vertex there, and you got this. So really the only part of the graph is the curve. None of this other stuff. That is just to help me make those curves. All right, so I'm just going to highlight that a little bit. The yellow part is the graph. Now, the way that, or the definition of a hyperbola is, the formal definition is the set of all points in a plane such that the absolute value of the differences from the foci is constant. Okay, now I guess I should discuss the foci as well. And I'm going to write this as this particular form: x squared over a squared minus y squared over b squared equals 1. So that's my general form. The foci, plural for focus, to find that distance from the center is kind of well, it's not kind of, it's like the Pythagorean theorem. C squared equals a squared plus b squared. So the foci would be c units from the center along the main axis that goes through the vertices. So in our problem here, c squared would equal a squared, 2 squared, plus 3 squared, or 4 plus 9. C squared would be 13. C would be plus or minus square root of 13. Now, square root of 13, that's square root of 9 is 3. So it's a little past 3. It's between 3 and 4 here. So I'm going to put this point here. It's the square root of 13, 0. 1, 2, 3, a little bit here. And this is the negative square root of 13 and 0. And I did this so that we could actually kind of look at this definition. All right, I've got a focus here. I got a point here. If I take this distance minus this distance and take the absolute value, that would be the same as a point down here would be this distance minus this distance. The difference between those is the same as the difference between those. And all the points that satisfy that fall on these two curves. So that is our formal definition of a hyperbola. This is how we find the foci. I've got the A under the X and I got the B under the Y. But if I were to rewrite it, and let's say, so the curves are different, I'm going to keep the A under the first part, the positive variable. And this is this B will stay under the negative variable. Just, it'll help us, I think, a little later. But all right, I did want to talk about something else. This is okay. A little more that is the transversal. This axis right here that goes through both vertices and both foci is the transversal. So I want to keep that in mind. Now, I've set this up. If I have another equation in this form, then let's look at y squared over 16 minus x squared over 9 equals 1. All right, so let's go ahead and graph that. I'll draw my axes here. And now this is y squared over 4 squared. So I'm going up 1, 2, 3, 4 here, and down from the origin 1, 2, 3, 4 here. Go 3, 1, 2, 3 here, 1, 2, 3 here, and I'm going to draw my box. And the box again is just a framework for drawing the actual curves. Now, okay, I wanted to make those dotted lines instead of, because I'm drawing asymptotes now. Okay, now, I didn't plan ahead very well, but the curves, I'm drawing right through my equations here, are right here. And there's a vertex, and right here is a vertex. So these are the curves. So again, the actual graph is just this part. All this other stuff helps us to draw these curves nicely. Now, the next thing I want to talk about, let's get the foci on this. So c squared equals a squared plus b squared. And in this case, this is a squared. So I'm going to go 16 plus 9. C squared equals 25. So c is plus or minus 5. I want to take the square root. Let's see, 1, 2, 3, 4, 5. There is one focus, and here's the other focus. It is 0, negative 5, and 0, 5 are the foci there. So you can see the directions on both of those. And the next thing I want to talk about is, now these are all going through the origin, so the y-intercept is 0. If I do okay. All right. So I was talking about the asymptotes. I actually had someone come in, so I needed to take care of that. These asymptotes, if you look, if I go arise over run, that's 3 over 2. And the y-intercept is 0, so y equals 3 over 2x. If I go down 3 and over 2, y equals negative 3 over 2x. And if you notice, the 3 is the b value, the 2 is the a value, and that would always be the case. So our asymptotes, if we are centered at the origin, is y equals plus or minus 3 over 2x. Oops, that's not what I wanted to do. I wanted to do b over ax. That's when your transversal is horizontal. Now, when your transversal, if we keep it like this, is vertical, this is the transversal axis, then and these are asymptotes. If you'll notice, we're going up 4 over 3, so the slope of this one is 4/3. This is the a value. 4 is the a value on this problem, and 3. So on this one, when you have a transversal that is vertical, y is equal to plus or minus a over bx. Those are the equations that will give you the two asymptotes. Okay, once again, those are asymptote equations. Okay, I'm going to, this is kind of the informational video, getting this introduced and getting some basic hyperbolas drawn. I'm going to go to a next video for other examples.